for the network of BGP is modern gateway routing protocol. We use version 4 of BGP. It is generally used to connect different autonomous systems, and it is used for connecting different organizations or an organization and an LSP. So here we see how configurations can be done for the same. The first thing that we need to do is to configure IP addresses for the PCs and the routers, so that we can do the clicking on the PC, going to desktop if it is not selected, and then we go into IP configuration. Here you can give the IP address and then mask the permanently, and similarly all the other PCs can be configured as well. And we go to the router. If we give the command enable, we can go to previous execution. From here, if we go to show any configuration, we can see all the configurations that are already made. So here we see that the interface commands are given. So for example, if we consider f0, after giving this command, we give the command for IP address, and the IP address and the subnet mask for the network. So similarly, all the required interfaces of the routers are configured with the IP addresses. So the next thing that we need to do is to configure OSPF for the internal connectivity of the autonomous system. Any other IGP can be configured as well. Here we are using OSPF. So here we give routing OSPF and the process ID, and then we see the networks that are directly connected to the router. Since we are considering only the autonomous system, only the networks that are present within the autonomous system, we are not specifying the serial network, we are specifying only the LAN. So here we see a network and then the network address, and then the wildcard mask, and then area and 0. We are considering single area OSPF, so we are using only area 0. And similarly, the other networks or other autonomous systems are also configured with OSPF for their internal connectivity. The next thing that we are going to do is to configure BGP. Alright, here how we do this, we give the command router BGP and then the autonomous system number. So here the autonomous system number is 100. So we give 100, and then after giving this command, we configure the neighbor for BGP. So here we have for every autonomous system a named router. So we consider all these X routers as broader BGP routers, and we are going to use all these routers for BGP configuration. So here for R1, we see that this interface is connected to CLF20 interface of R2. So this interface is considered to be neighbor. This router's AC20 interface is considered to be neighbor for R1. So we give the command neighbor, and then this interface IP address, which is 10.0.0.2, and then we say remote AS, and then we say the autonomous system of the router, the autonomous system where this router R2 is present. So we say it is 200. So similarly, if there are multiple neighbors, multiple network masks can be given. And then we also need to advertise the networks which are present internally to this router. So we need to give the command network, the network address of the network that is present here, which is 10.1.1.0, and then we say mask, and then we say the subnet mask of this network. So the next thing that again, if there are multiple networks, multiple network commands can be given. Then we say redistribute OSPF 1, so that the OSPF that is configured internally can be redistributed via OSPF to the other autonomous systems. So similarly, the other two routers are also configured with BGP. Let's check the router 2 for one more example. So here again we need to say enable, and if we say show running configuration, we can see all the configurations that are made. But actually these configurations are supposed to be made in global configuration, which can be accessed by using configure terminal command from privilege execution. So here we again say router BGP. After configuring OSPF here, we say router BGP, and then the autonomous system number, which is 200. And then here there are two neighbor commands configured, because this router has two neighbors, R1 and R3. So we say neighbor, and then this IP address of this interface of the router R1, and then we say remote AS, then we say the autonomous system where this router is present. Since it is 100, we say 100, and then again neighbor command is used. The IP address of this interface we say, and then we say remote AS, and then we say the autonomous system where this router is present. So we have configured the neighbors. We have to again tell others about the network that this router is connected to, or the internal networks to this router. So we say network, and then the network address of this LAN, and then we say mask, we say the subnet mask for this particular network. Again we say redistribute OSPF 1 command, so that This one is the process ID. So this command is given so that OSPF will be redistributed into the BGP. So similarly for R3, BGP configuration is given enable and then show and configuration so that we can view the configurations that are made. So here we say router BGP in the autonomous system method. And then we say we configure the neighbor, this IP address, and then say neighbor 172.16.0.2 and the remote AS and the autonomous system where R2 is present, that is 200. When we say network, the network that is present internally, and then mask and then the subnet mask for the site. So redistribute OSPF. So here ends a configuration for BGP. Let's check a few troubleshooting commands. Let's start with R1. So here let's use the command show IP BGP. So we see various networks that are run via BGP. So we see that these networks are run via BGP, and the next thing that we need to look at is show IP BGP neighbors. So here we see that this router R1 has only one neighbor, which is R2. So here it gives the details of the neighbor. We saw show IP BGP, then we are seeing show IP BGP neighbors. Okay, here we see the neighbor's IP address, and then we see which autonomous system it belongs to, and then we see the version of BGP that is used, and then a few other details, hold time, keep alive interval, all this. And these are the different types of messages or packets which BGP uses to establish BGP connection. So here it displays the number of such messages that are being sent or received after BGP is up. There are also few more details present. So if we see, okay, this is the one we saw right now. Then the next is address family that we are using is IPv4. BGP table also has a version, so this one uses version 11. So there are a few more details that are present over here. So these details are present for this router. The same command, if we go and check in R2, we will see that there are two neighbors that are present, and two sets of such details will be displayed for R2. So let's see now, show IP BGP, then summary. Now this will display the summarized details of the BGP that is configured. So here we see that BGP router identifier is this. So that will be this router's one of the IP addresses, and then the local AS number, the autonomous system to which this router belongs to, and then we see again the BGP table version, and then we see the number of network entries, so the number of path entries and the number of bytes that are used in memory for each of these entries. And we also see that the number of path attribute entries, and then the amount of memory that's used for it, the ASPath entries that are made, and then the route maps and the feeder list details that are present here. We are not configured any, so it's showing 0, and the total amount of memory that is used. And finally we also see the neighbors details that are present. So let's check the same command for the other routers as well. If we check the router R2, we have two neighbors details for every one of these commands. If we check show IP BGP, will give us the normal BGP configuration details. The table version and the router ID is also present. If we check show IP BGP neighbors, we can see that the BGP neighbors 10.0.0.1 remote AS 100 externally. So this represents this R1 router, which is the neighbor for the router R2, if we go down, we can see all of these details about this neighbor, and if we further go down, we can see that the other neighbor's detail is also present. BGP neighbor 172.16.0.1, which is this router. So remote autonomous system 300. So the details about this neighbor is also present for R2. So if we check show IP BGP summary, we will see that again here we have got two neighbors details instead of one neighbor which was shown by R1. So let's also check show IP route. So here we can see the routing table entries. This router has got one LAN, these two serial links directly connected to it. It doesn't know the details of this LAN and this LAN, which are present in totally different autonomous system. So here we see that all of these directly connected links have got the character C for it, and for these two LANs, which is 10.1.1.0/24 this LAN and LAN 172.16.1.0 this LAN, these are shown as B, which means this router has got the details. This router has got the details of these two LANs by means of BGP protocol. So similarly, if we go and check the other routers, we will see that the routes that are from the other autonomous systems will be sent to it by means of BGP. So it will be shown by the character B. So let's now check the end-to-end connectivity of the devices. So for example, this PC address is 172.16.3.2. So from here let's check PC1. From PC1 we are trying to connect to PC4 and we are getting reply for the request. So we see that from one autonomous system to the other, we are able to configure external gateway routing protocol, that is BGP version 4, and we are able to connect it. Let's also try to check some other PCs, like for example from PC2 to PC5. Let's try PC5's IP address is 172.16.1.1. So if we go to command prompt and type 172.16.1.1, we can see that we are getting the request, so it's able to connect to PC5. Now let's finally check these two autonomous systems connectivity. Let's go to PC3 and try to connect to PC6. So the IP address of PC6 is 172.16.1.2. So let's say from here 172.16.1.2. So we are able to again get the reply. Thus we are able to connect from one device which is in one autonomous system to some other device which is in some other autonomous system by means of eBGP, external border gateway routing protocol. Thank you.